In this lesson, we're going to look at prime and composite numbers, which is something that we introduced in elementary. I really like to start this by doing a little activity and kind of talking about areas. So I'm going to switch over to just a blank sheet. And to begin teaching prime and composite numbers, what I think it is a good idea to do is to give these students this problem and see what they come up with. So I would give them maybe a piece of grid paper or even just a blank piece of paper, and I would tell them come up with all the different rectangles that have an area of 5. And so have the students in third grade, they begin learning the concept of multiplication and area of a rectangle being length times width. So I would give them a piece of paper, grid paper, or even just blank paper, and say, come up with all the different rectangles that would give an area of 5. And then also have them come up with all the different rectangles that give an area of 16. And give them some time to work on that and see what they come up with. Now, in the end, you're going to go over this, but let's say, they come up with an area of 5, so that's a 1 by 1, 2, 3, 4, 5. So they should come up with a rectangle of 1 by 5, and 5 by 1 is basically the same rectangle. It wouldn't be a different rectangle. So to come up with an area of 5, the only dimensions that would work for that rectangle would be 1 by 5. If they also look at the area of 16, they're going to come up with multiple different rectangles. So they could come up with a 1, 2, 3, 4 by 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. They could come up with a 4 by 4 rectangle because that produces an area of 16. They could come up with a 1 by, let me count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, and I hope I counted that right. But that's, if not, it's okay. This is just an illustration. So they could come up with a 1 by 16. They could also come up with, or should come up with, a 2 by 8. 1, 2, 3, 4, 5, 6, 7, 8. So a 2 by 8 would also produce an area of 16 because 2 times 8 is 16. And so they would have multiple different rectangles that produce an area of 16. And I like this illustration because it very plainly models the difference in a prime and a composite number. A prime number, by definition, only has two distinct factors. It's only divisible by 1 and itself. And if we look here, this rectangle with an area of 5 only has the dimensions of 1 and 5, which is what 5 is divisible by, 1 and itself, which models the concept of a prime number being only divisible by 1 and itself. And that's the only way to come up with an area of 5. You could also use 7 because a 1 by 7 is the only way to come up with an area of 7. When we consider a composite number, by definition, a composite number has more than two distinct factors. And so when I think about an area of 16, I get these multiple rectangles because 16 is divisible by 4, and it's divisible by 16, and 1, and 8, and 2. It's divisible by more than 1 and itself. It is divisible by 1 in itself, 1 and 16, but it's also divisible by 2, 4, and 8. And that models a composite number because it has more than two distinct factors. It's divisible by more than 1 in itself. So you could model here that 5 is a prime number where 16 is a composite number. Now, if you go back to your notes, I start the notes with the definitions of these two words. A prime number is any positive integer that has two distinct, and a keyword there being distinct, positive factors. And basically what that means is prime numbers are divisible by 1 and themselves. Those are the two distinct factors. So like 3 is a prime number because 3 is only divisible by 1 and 3, 1 in itself. A composite number, by definition, is any positive integer with more than two factors. So it's divisible by more than 1 in itself. So for example, 9. 9 is divisible by 1 and 9, but it's also divisible by 3, making it a composite number. Now, I do want you to note that 1 is neither prime or composite because 1 is only divisible by 1. And by definition, it has to have 2 distinct factors, and that means 2 different factors. So 1 is only divisible by 1. Yes, 1 times 1 is 1, but that's not 2 distinct factors. That's the same factor. And so that's the why on why 1 is neither prime nor composite. Now, another activity that I really like to do when teaching prime and composite numbers is to pull out the hundreds chart. And that's the next activity that I'm going to go over with you before we even start the problems in our notes. So another excellent activity to really reinforce the concept of prime and composites is to pull out the hundreds chart. And this is something that students are familiar with at a very, very young age. And you can use this to go through and model prime and composites and prime and composite numbers and why that is so. So when I do this in my class, I hand out the hundreds chart and we start with the number 1. And we just note that 1 is neither prime or composite because of the definition that we just went over. It doesn't have 2 distinct factors. The only thing 1 is divisible by is itself. And then we say, okay, well, what about 2? Is 2 prime or composite? Well, 2 is prime because the only thing that 2 is divisible by is 1 and itself. And so what I'm going to do is I'm going to highlight the prime numbers. And so 2 I'm going to highlight as being prime because it's only divisible by 2 in itself. But what I know after that is that every even number after 2 is composite. And the reason it's composite is because every even number after 2, bigger than 2, is divisible by 1, itself, and 2. So let me tell you why this is so. 4, for example. 4 is even. It's a multiple of 2. 4 is even. 4 is divisible by 1 and 4, but because it's even, it's also divisible by 2, and that's what makes it composite. And so what I can do is I can mark out every even number larger than 2 as being composite, and all of these ones that have a blue line through them are going to be considered to be composite because every number that I just marked out, all of these numbers are divisible by 1. All of these numbers are divisible by whatever the number is themselves, and all of these numbers are divisible by 2, and that makes them composite because they all automatically have more than 2 distinct factors. So all of those get marked out from that. Now my next prime number is 3. So I'm going to highlight it because it's prime. But then every multiple of 3 would be composite because every multiple of 3 would be divisible by 1 itself and 3. And so I'm going to go through and mark out all the multiples of 3. So 6 is already marked out, but 9 isn't. 12 is, but 15 isn't. 18 is, but 21 isn't. And I'm marking these out because these are all multiples of 3, making them divisible by 1 themselves and 3, getting those 3 factors, which makes it not composite. After 21, 24 is already marked out, 27 is not. 30 is already marked out, 33 is not. 36 is already marked out, 39 is not, so I mark it out. 42 is, 45 isn't. 48 is. 51 isn't, so mark it out. 54 is. 57 is a multiple of 3, so we mark it out. 60 is already out. And then we have marked 63 out because that's a multiple of 3. Then 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, and 99. Now one more time I'm going to say the reason these were marked out is because they are all multiples of 3. That means that they are divisible by 3, but they're also divisible by 1 in themselves, which makes it a composite number. Now my next prime number would be 5, because 5 is only divisible by 1 and itself. But all of the multiples of 5, right here, And over here, all of these 10s, which are already marked out, would be marked out as being composite because all of those numbers are divisible by 1 themselves and 5, making them have more than 2 factors, which would make them composite. Then I say, okay, well, 7 would be prime. And then I would go through and do all the multiples of 7. And then I would have, I would mark 11 as prime. And I'm not going to finish this whole thing with you. I hope you understand the point here. But this is a really good activity, and you would just continue this on, highlighting the prime numbers, marking out the composite numbers by going through multiples. All right. I'm going to end this first video, and then in the next video, we'll go through and we'll actually begin going through the practice problems in the notes. But I just wanted to show you 2 really good activities to get you started if you're actually teaching prime and composite numbers. These are 2 excellent activities to start with.